Hi everyone, welcome. My name is Tunde. I'm a senior engineer at VMware, and in this video, I'll be walking you through recovering ETCD from a majority failure. But this time around, we're going to be doing using a flag called dash dash force new cluster. In the last video, we looked at recovering using a snapshot restore. And now this time around, what we're going to be doing is forcing the creation of a new cluster while retaining existing application data. So let's get right into it. So I do have my environment. I do have 3 control plane nodes and a single worker. And we can, as you can see, we have the cluster running Kubernetes version 1.17.0, and each one of them has a status of ready. And if I run kubectl get pods -a, that is all namespaces, we can see that all etcds are running. So what we want to first do here now is to simulate an etcd failure across all 3 existing etcd nodes. So I'm going to quickly do that by first removing, first let's verify that etcd is running. So we'll run a couple of verification commands. Etcd member list shows the members, and etcd endpoint else returns lt if the endpoints are lt. That's not what I meant to do. All right, great. So we can see each one of them. So let's run that again. We can see each one of them returns that the endpoints are lt. Great. So we verified that. Now the next thing we want to go ahead and do is remove the etcd data directory. Nope, we want to simulate a stop of the etcd containers. So right now, let's verify. You can see that the etcd is running on each one of the as a container on each one of the control plane nodes. So what I'm going to go ahead and do is move the static pod manifest away from the static pod manifest path inside of the nodes to another directory. And so I've simulated that, and now if I do call ps, you can see that very soon etcd should no longer be running. Let's see. Great. We have just verified that etcd is no longer running across all of the control plane nodes, and if we run kubectl to get nodes across each one of them, we shouldn't be able to get to the API server because the cluster is pretty much in a degraded state right now. So let's go ahead and get into recovering this etcd cluster. And so the way to do this, first we can just choose one of the etcd nodes existing inside of the cluster and force creation of the new cluster from that specific etcd node. So for the purposes of this demo, last time I did this from control plane 2. This time around I want to do it from control plane, the first control plane. So what I'm going to go ahead and first do is to open up the etcd YAML files for each one of them. And what I would do is on this first control plane, I'm going to go ahead and make a couple of changes. The first thing is to introduce a new flag. This new flag is the dash dash force new cluster flag, which is a boolean. So it's either true or false. In this case, we're forcing new cluster and we're specifying true. So what does dash dash force new cluster do? So what it does is it allows the cluster to, like says, force the creation of a new etcd cluster while maintaining the existing application data. So Another thing we will want to change here is change the initial cluster state from existing to new. And then we want to specify the initial cluster to be we want to specify it to be just the first control plane, in this case, which is just the DB control plane with the IP address of 172.05.2380 port. So I'm going to go ahead and delete the subsequent ETCDs from the list. Great. So that's pretty much all we have to specify. There's really not much to change. The listen peer URLs remain the same. The advertised peer URLs also remains the same, and also the client URLs will remain the same because we're still running on the same node. So I'm going to go ahead and save. And now that I've saved this, what I'm going to do is just simply move the ETCD YAML files back to the manifest directory. And what you would notice is the ETCD port should slowly come back up. Okay, so let's verify again. So yep, we can see that ETCD is now running, and then we should also be able to reach the API by running kubectl get nodes. It might take a little bit, but slowly we should be able to reach that. But we can just verify by run ETCD member list. Yep, we can see that one member is back up. So we're in a good state now, but we need to get to a state where ETCD reaches quorum. So what we want to do next is to join the subsequent ETCD members to this new ETCD node. But prior to doing that, one thing we would have to do is remove the ETCD data directory from the subsequent node, so that the old information doesn't conflict with what's in the new cluster. Also, we need to also change the initial cluster state on the static port manifest for the subsequent ETCD node. So what I'm going to do is remove this based off how we're going to be joining. For the first one, since we're joining, I have decided to join the control plane 2 next. And so what I'm going to do is remove control plane 3 ahead of time. And I'm going to do etcd ctl member had, and then specify the name of the node that I would be joining in this case, which is db control plane 2. And then we want to specify the peer URLs, and we want to say https, and then specify 172.17.0.4, which is the IP address, and also the peer URLs port, which is 2380. Okay, we've specified that, and now the next thing, we've informed the ETCD cluster that that we're trying to add a new ETCD member, and now it's letting us know that we're trying to add DB control plane 2, and that the initial cluster state should be DB control plane 2 and DB control plane, and the advertised URL should be 172.17.04 and using the port 2380. So hence why I have changed this from this initial cluster to match the same thing. And also, if you notice, the initial cluster state in this output here 6 existing, and same thing applies to this cluster. So we would have to add the initial cluster state as existing in here. So let me just change lines. So okay, looks like we have everything checked out right, and so we can save. And now that we have that right, what we can do is move the ETCD manifest back to the appropriate directory in here. Great, and then we can do call to PS here, and we should slowly have ETCD come back up, unless we configured something wrong. Okay, let's verify that manifest again. So we have our peer URL set as 0.4. The initial cluster state is 172, and DB control plane is 172.17.0.4. Okay, so looks about right to me. I'm going to do ETCD member list again. So we have this peer URL specified accurately. So let's do call to PS. Oh yeah, so we forgot to make one change. So let's move ETCD CTL back. Okay, and so what I'm going to do is do 3 of var lead ETCD. All right, so looks like we still have the data directory here. So what I want to do is remove this data directory and go ahead and do the ETCD member hat command again, and then move back the ETCD YAML file back into the manifest directory. Great, we've done that. And I expect this to fix the previous issue. Great, so you can see now, looks like ETCD is back up. So yeah, we have to remove the data directory prior to trying to add the old members back to the cluster. So right now, if I do an ETCD member list on this node, we can see that we have 2 started. Let's make this a little bit much more cleaner. Maybe that's not the best of look, but so yeah, we have this one joined. Now let's join the last one, and simply what we want to do is specify the name as control plane 3, and also specify the right IP address here, which is DB 172.17.06 for the third one. So I've specified that, and now you can notice that the initial cluster has also changed. Right now, it includes DB control plane 2, and then the new control plane that we're adding, ETCD control plane member that we're adding, which is DB control plane 3. And so we would have to also verify here that the initial cluster state matches what we have in that output that the member add command had returned, which in this case has the all ETCD members. listed, which is exactly what we're wanting, and also the initial cluster state existing matches what we have here as existing. And the advertised PRL matches, and every other thing looks like it checks. Okay, great. So what next? So what we have to do is save that. And now that we've saved that, we have to remove the old data directory, which is var lib etcd. And now that I've removed that, you might be wondering how I figured out what the data directory is. And one of the easiest way to figure that out is by looking at this flag here. So you could customize the data directory to be at another path. So in this case, my data directory is var-lib etcd. So I'm going to save that. And what we want to do now is move the etcd pod manifest back into the static pod manifest directory. So let's do that. And I've moved that now, and if I do query ps, we can see that etcd is back up running. So etcd is running, and if I run etcd ctl member list on this specific node, you can see that it shows all members is running, and on the etcd node at the middle, also you can see that we have from there also I can still interact with the etcd cluster and see that all etcd members are back inside of the cluster. So if I do etcd, so one thing I would like to do across all nodes is verify the endpoint elt. So one way to do that is to run etcd-ctl endpoint elt, and you can see they're all running lt. So now let's verify that we can interact with the Kubernetes cluster again. Okay, so we're able to return the nodes in the cluster, and if I check the pods in all namespaces, we can see that we have Nginx running, we have etcd running, and the cluster seems to be back at an LT state. And that's it, folks. That's the other way you can install recover etcd from a majority failure. And in the subsequent videos, I'll be talking about some of the best practices for maintaining etcd, and also building a recovery process around etcd. Leave a comment, leave a like, subscribe. Thank you. Bye.